so good. Must be from Mars.
3D printed RC trophy truck Ford F-150, the next chapter in our undestroyable printable RC journey. 8 big shocks with an independent front, a proper rear trophy truck suspension with trailing arms, conventional and flexible body, roll cage, some interior design, heck, even seats. Someone gonna be inside? This project almost never got finished. Designing the chassis took a long time, almost forever. 6 months, baby. The new innovation, the shatterproof body, constantly failed at mid-print, causing some seriously heated midlife crisis.
What is this? What is this? Will this ever work?
I don't know. Achieving optimal steering angle at first seemed almost impossible in this 1/10 size. But we emerged victorious from all these issues. 3D printable, undestroyable RC cars. Is that even possible? On this channel, we work towards reaching that dream.
We are the RC Twin Builders!
Infiniti closely has a trophy truck chassis, but not quite. It seemed forever to design it and have these trailing arms, but finally we can call this a proper trophy truck chassis. God, I bet you guys want to see that in action. To build this chassis, we need filament, lots of M3 screws, a few of this bearing, and of course the RC necessities. We're still aiming to keep costs very low, because it's way more fun to polish a turd and make it fly. Our previous chassis, Infiniti, is infinitely adjustable in the 1/10 size. This one is not. Its size is set to the body. As we are unfortunately not omniscient, we might overlook something you can immediately spot throughout this journey, so just tell us.
Do not hesitate to tell us, because we are doing this together with you.
We need your comments.
This was his ever first English speech recorded. He did it, but he was reading it. Sorry, I speak only English, but he's the designer.
Here you can see the gearbox, which has a 1-to-3 gear ratio. It's basically the same as in the previous project. The motor has a higher RPM than we used before, 27,000 electric brushed. The car top speed will be around 50 kilometers per hour. Gears and the 2 shafts 3D printed from ABS for better mechanical properties. Gearbox housing was printed from PLA. The shaft is printed in a horizontal position in the best possible orientation for maximum strength. Assembly is also simple. You just insert it into the gear. And right after that, you just put the bearings on. There's been a small improvement at the output shaft cup. We changed the shape lock connection to this clover leaf pattern, which previously was either 2 half shafts joined together or a hexagonal shape lock connection. Previous solutions proved too weak as they sheared under heavy load. We tested this new one and so far it's holding up really well. We also used the new shape lock connection on the printed pinion gear. What do you think about this design? Can this be further improved? If you have any idea, let us know. Here you can see the drive shaft. This is how it can shift to the desired length while the rear axle goes up and down when the car is in motion. We'll try to show this in action a bit later. Most important note here, you have to print all these parts with 100% infill. The ball head has been redesigned. Here you can see the older solution. During testing, it became clear that the neck diameter was too small, which caused it to break at the thinnest wall thickness. We also removed a part that later proved to be completely unnecessary. The enlarged diameter and leaving out that cylindrical part allowed us to increase the wall thickness, and now the ball head can withstand the load. Do you guys think we are on the right track with this? Let us know. Here's how we secure the cup to the ball head with a simple screw. For the differential, the input gear can be either 3D printed or made out of metal ordered from eBay. If you choose to print the pinion, print it with 100% infill. We recommend using ABS. Here's how the assembly of the metal pinion gear to the cup looks like. Bearings, pinion, and the screw. Soon we'll demonstrate why using metal gear differential is preferable compared to a printed bevel gear set. Now comes the rear axle. First, the housing. We also have improvements here. These reinforced strips on both sides and the option of your choice, the 2 alternatives. Fully 3D printed rear axle or the eBay metal differential can both be fitted into the housing. Here's what the fully 3D printed rear axle with the pinion looks like assembled in the housing. There are 6 bearings. Both the axle and the gear should be printed with 100% infill using ABS. Don't forget to put lubricant on the gears. If the infill is not 100%, 100%, the bevel gear can look like this after some good minutes of playtime. Let's see the other alternative, building with the eBay metal differential. For better stability, we also use 2 additional bearings. The 2 half axles must be printed 100% infill using ABS, but we also tried using PETG. It looks okay so far.
We recommend using this because this is a proper differential, very reliable and almost never gets worn out. Only $10 from China!
If you have any ideas how the printed version can be improved, maybe a different material or different design, let us know in the comments. Regarding the rear axle, Bro tried several different designs. In the end, the one-piece printed version was the winner. Bro thought that separating the design is the way for a lasting version. Optimal printing orientation helped us many times with many parts, but this time you can see it let us down. Mainframe and the trailing arms. Trailing arms which are attached to the mainframe using a single M3 bolt. We use 80mm suspension for each side. Trailing arms have held up well during testing, which you will see soon, and haven't broken yet, so we believe they are thick and strong enough. The rear axle is fixed to each trailing arm with 1 bolt at the bottom. As you can see, there's a ball head inside in each link bar fixing joints, so countersunk head screws are used instead of normal ones. Don't tighten the screws completely, leave a bit of slack so it can move slightly. The gearbox is fastened to the frame using 4 screws. If you want to attach a GoPro camera or anything, you can use these holes to fasten the camera. Front suspension holder and the rocking arms and the steering, which are fundamentally carried over from the previous project, Infinity. Overcoming all the upcoming issues and applying new design principles like greater steering angle by implementing Ackermann steering geometry, minimizing steering link-induced wheel movement. Boy, achieving all this was much harder than it seemed at first glance. Let's see these issues one by one. Greater steering angle at the wheels. We had to come over many tries until we found the perfect one. The length of the steering rod sometimes was too short or too long and collided with the inner suspension. Something in the designing program is not always feasible in reality, so you have to print it over and over again and test it many times. Modifications were made to the rocking arm and the suspension holder. We repositioned the mounting points of the inner spring deeper inward to allow for shortening the steering arm. This design change makes it possible to achieve a greater steering angle with the same rack travel. You guys have any ideas how to further stretch the steering angle? If you do, we'd appreciate if you shared it. Let's see the second major design change. We are implementing Ackermann steering geometry for optimal turning path to this chassis. What is an Ackermann steering geometry? Here on the first picture you can see the red dashed lines run from the inner pivot of the steering arm through the kingpin of each wheel and intersect at the midpoint of the rear axle. This second image shows how the principle works when the chassis turns. The extended direction of the wheels intersect at the center of the turning circle. As you can see, the left wheel turns more. Alpha is bigger than beta. This ensures that the inner and the outer wheels follow the curve rolling without any of the wheels slipping during a turn. Altogether, the chassis turns more easily on this correct arc.
Chassis has Ackermann.
The third improvement of this section is minimizing steering link-induced wheel movement during full suspension compression. The goal was to reduce unwanted steering input caused by suspension travel. For this reason, we modified the steering bar with the rack, testing several design variations. This version proved to be the best. The ball head snap fit connectors were moved further inward and slightly higher to allow more free movement. Additionally, the base position of the 2 outer steering links is now steeper, resulting in less wheel movement caused by the suspension compression. What do you think about these improvements? Let us know in the comments.
Or your IQ is over 327, and you have at least a dozen ideas how to make this chassis even more badass. Time to let us know would be now.
Under the video.
We have means to reward you. Back to work.
The wheel design has also been modified.
The main consideration was to make the main body of the rim printable in a single piece. It now consists of 3 parts assembled together. This piece must be printed with at least 50% infill. If printed with only 20, the screw can deform the surface when tightened, as shown in this case. The tire can either be 3D printed, as you can see in this design, or you can get this eBay version, which we personally prefer. In theory, 3D printed tires can work, although their reliability is still not even close to an injection molded piece. If you guys 3D print tires, we'd like to know how it went. Please help us, comment below.
Here comes the receiver. And this is how we fix the motor controller with a bracket.
This is the battery bracket. As you can see, we have a little printed invention here, which makes your life much easier when attaching the bracket with the battery to the chassis. This design will feature seats. Who's gonna be in it? The chassis has been assembled, and we have someone here.
Shit, I'm alive.
He's gonna be helping us testing our cars.
What?
He hasn't got a name or a face yet. We need your help. Give him a proper name, or maybe even ideas who says he should have. The most liked ideas in the comments will get silver memberships on our website for a year. This guy is already training very hard for testing of this truck.
I love my job when not testing. I can be so lazy.
You don't take your job serious.
Drop me 20 more push-ups.
Yes, boss. Number one.
By the way, this 110 chassis still need to be named, just as in case in our previous projects Infinity and Destiny, you have to give a name in the comments, and the one which gets the most likes will win, and the person gets a 1-year gold membership on our website. Till the naming happens, we call him number 3. We've just arrived to the bodywork. We're gonna do it the conventional way using PLA. And in a couple of minutes, out of something wobbly. The Ford F-150 got mentioned by you most frequently, so as lawyer servants, we immediately started to work and come up with something relevant. We always listen to you if you give the input in form of comments below our videos. The parts have already been sanded. Oh, sanding. Peacefully dreaming about what girls you're gonna bump into Saturday night? No! You're sanding even in your dreams. And every places. Reaching a shiny and smooth surface takes still eternity. But we have one friend, liquid soap. Speeds it up a little. Obviously using rougher papers first. Assembling this version only takes a couple of seconds.
Couple of seconds, my.
What'd you say?
He got separated.
Only a nameless testman yet. All the body parts were printed with 0.2 layer height. Creality... Creality did not pay for this, but we have a comment in favor. Layers are sticking to each other very well using this filament. If you guys have any questions regarding the body, do not hesitate to ask us in the comments. For filling larger gaps, we use
Tamiya Putti.
Worst ad ever.
car body filler would be perfect, however, it's almost impossible to smooth back. Do you guys have any other suggestion what we should use instead of this putty? We've never used anything else, to be honest. Putty has been applied to most of the surface. We try to apply a very thin layer so that sanding would not much be needed. But still... We don't want to scrub all the putty off, so we're gonna use 400, 600 and 1200 sanding papers. I wanted to paint the body yellow with some cool black parts, but my brother wanted this baby blue.
I was the one designing it, so I'm gonna be telling what the color will be.
What do you guys think? Would you paint it differently? We have this wonderful color, we're just gonna do some garnishing. Spray in a protective varnish layer as well. Wobbly body! Bro had a great idea. What if we printed the body out of TPU? Imagine it won't shatter into pieces if you drive the car into something.
No brakes, bro.
So we jumped into it and it ended up with 2 weeks of constant testing. Oh. How was it, brother? Oh, you have to read it.
At one point I was ready to give up completely, but I kept coming back again and again until, with the right print settings, some minimal printer modifications and a few design tweaks, I finally made it work.
Bravo, bravo, maestro! Printing with TPU is not the easiest because of its flexibility. It's available in several hardness grades. For RC body printing, we need the hardest TPU possible, at least Shore 95A. We also tried printing with a softer TPU, but those attempts completely failed. There's also the 98A version, which is really hard to get. We couldn't get it, so we had to rule that out.
Oh, God.
If you guys have experiences with the harder TPU, please share it in the comments below.
Printer settings.
Seriously?
If you have a printer with a direct drive extruder, feeding the flexible filament will be easier. Their design is simpler. We have a Bowden setup, so we had to make a few modifications. Shortening the PTFE tube, this way the filament is pushed through a shorter distance, reducing the friction caused by the tube. But the most important thing is extruder gear tension. Since TPU is flexible, it compresses easily, so you need to reduce the gear's pressure. On this Ender 3 V2 Neo, Bro solved this by setting the tension spring to its loosest position and even removing the spring plate. To avoid flex material jamming, we made this plastic tube bleeding the filament into the PTFE tube right after the extruder gear. Cut it in a V form, inside diameter 3, outside 4 millimeters. Our TPU print settings: nozzle
0.4,
layer height
0.2,
print temperature
215,
bed temperature
80.
Despite using adhesion spray, we continued to have warping issues until we raised the bed temperature. Initial layer print speed
10 mm per second.
print speed after the first layer
30 mm per second.
fan
Full speed. TPU layer stick valve.
retraction
5 mm. If the extruder tension is set correctly, retraction won't cause problems.
For more detailed settings, here are some Cura parameter screenshots. Because 30 millimeters per second print speed is slow, print time increases significantly. To compensate, you can increase the nozzle to 0.6 and the layer height to 0.3. This will save you a lot of time. However, in that case, make sure to disable retraction. Design adjustments for TPU. These parts clearly show how poor the upper sections turn out when printed in TPU. Once a certain Z height is reached, the printed part loses stability, noticeably from around 100 millimeters upwards. Because of this, the hood and the two rear side panels had to be split into two smaller sections. The hood's PLA version is in one piece. We added a little extra at the side window for TPU printing, as it is obvious that a little support is needed for a cleaner final result.
This is how it
Came to be. We will test this body in a minute. You guys happen to know better TPU print settings or had any experience with this subject? Please share it with us. Here's the front bumper with the lights and the grille. This design is fully supportless. No supports are needed anywhere. Parts just snap together and can be glued afterwards. The light housings were FDM printed from transparent ABS, but it can be done with resin printer as well. This is how the tail light comes together. The cover was also printed with ABS and then colored with a red marker. In real trophy trucks, usually there are no functional front and rear lights, but we wanted to give the option to install them. Three small pieces are the chase lights. We're not adding lights here for now, since we don't have enough LEDs in this light kit. An off-road vehicle is not complete without roof light, and ours won't be missing it either. Here's how its parts come together with the LEDs already inside.
What is this? Be organized.
We thought we further step into coolness and designed a roll cage into this beast. Fixing happens with these three knobs. This is how it looks on the chassis. We're just flexing now. When assembling the whole thing, you have to assemble the cage and the body first. Let's give this cage a nice red paint. Joining time! How cool is this on a scale 1 to 10? What do you guys think about the new design features?
Roll cage and the interior.
You think something's still missing? We'd love to hear your thoughts. What should we do next? We are completely clueless. The decision is completely in your fingers. Write it down below and we'll do the most wanted one.
Let's see what these two put together.
We are grateful for your support, guys.
We'd like to design so many cars with even more amazing chassis at the best deal to value ratio. Your support helps us get there, whether it's a piece of advice in the comments or your aid to cover costs.
I can't believe it. I'm supposed to be the test guy and you did not even jump me.
Careful what you wish for.
Another posing with the monster. Getting inside again. Ah, my legs! Flexing my arms, sitting in a way that commands respect. Gods of 3D printing, that's a ramp! Wait, I don't think I was designed to do this!
We heavily tested the TPU one.
It's massive. Believe it or not, there's no damage apart from these mud scratches. Did you like the testing? Give us some feedback.
Do not subscribe and miss our next project.
Bye.